Dear students, today we will start properties of matter. Today we are going to discuss about properties of matter. So in this properties of matter, the first property what we are going to discuss is surface tension. Surface tension. So generally liquids shows this property. Which property? Surface tension. So generally in liquids we will see this property. So now we'll try to understand what is surface tension and why surface tension is created in liquids. Why surface tension is created in liquids. So before going to understand surface tension, we have to understand two more forces. We can say two more intermolecular forces, that is cohesive and adhesive force. Which force it is? First one is cohesive and second one is adhesive force. First one is cohesive force, second one is adhesive force. Cohesive force means the force between the same type of molecules. Force between the same type of molecules called cohesive force. The force between two different molecules are called adhesive force. I hope you understanding, right? Force between two same type of molecules comes under cohesive force. Force between two different type of molecules is called adhesive force. That's why when we see glue, for example, camel glue is there or Fevikwik is there. If you see on the top, it is clearly mentioned. It is adhesive force. It is not cohesive force. It is adhesive force. Why? Because the glue attracts other bodies. So glue is one type of molecules. Other bodies having different molecules. In between these two, whatever the force is there, that force we are saying it is adhesive force. Clear? I hope you understand, right? So we'll discuss surface tension. Before surface tension, we have to understand these two. Based on these two only, we will explain surface tension. Clear? What are these two forces? First one is cohesive force. Second one is adhesive force. Cohesive force means the force between two. Force between, we'll write, no need of write two. The force between same type of molecules. Same type of molecules are called cohesive force. The force between same type of molecules are called cohesive force. And again here, force between different type of molecules are called adhesive force. Adhesive force. Clear? What is a cohesive force? Force between two same type of molecules and force between two different molecules is called cohesive and adhesive force. Right? Now we'll try to understand what is surface tension. What is surface tension? I already told you surface tension is the property of a liquid. See, for example, here one container is there. In that, up to here some liquid is there. For example, here up to here some liquid is there. Here some liquid is there, right? Now try to understand. I will try to explain surface tension by using 3 points here. So here, first point I will write here, this one, A. It is A, and here it is B, and here is C. A, B and C. But try to understand carefully. So here when we see here molecule is there. Surroundings also same type of molecules, right? Same type of molecules. So in between these some attraction force will be there. Attraction force will be there. So here force is attracted, here one force is attracted, here force is attracted, this one attracted, this one, this one, this one, and this one. So the net force acting on this particle is 0. Net force acting on the particle is 0. Why? Because it is inside the liquid. So throughout its surroundings, same type of molecules are there. So same force will be exhibited. When same force will be exhibited, the net force acting on this particle is 0. Clear? Now see the point B. Here the point B here. This one is A and this one is B. On the B, just try to understand. Here the particle is there, but this region, air particles will be there. Which particles? Air particles, right? So here on B, two types of forces will act. One is cohesive force due to the same type of molecules, and second one is adhesive force due to different type of molecules. So here one force will be in this direction, cohesive force, cohesive. So here cohesive, and here adhesive will be there. Adhesive will be there. Now try to understand. On the particle B, cohesive force is more when compared with adhesive force. Cohesive force is more when compared with the adhesive force. So if you see this particle, the net force will act downward. Net force has to act downward. Why? Because see here, just I am drawing like this. Example, if it is like this, correct? So particle is here. These forces, right? Maybe these two forces balance with each other. In this, net force will be in this direction. In this, net force will be in this direction. Correct? So remind, the net force between these two will act in this direction. So on this particle B, net force will act downward. So you may ask the question, sir, here also some air particles are there. Air particles are there. We know, even though air particles are there, so when we compare with the occupied property or occupied level, we can say here less number of particles will be allotted or accumulated. So due to this, the adhesive force is less when compared to the cohesive force. I hope you are understanding, right? Clear? Even though here half is there, here half. So now you tell me, for example, here one unit volume is there, volume of water. Here 1 unit volume of air is there. So can we say in both same number of molecules will be there? No. In water, more number of molecules will be presented when compared with air. In air, density is less. Water density is more. Density is more, which means more number of particles are there. So more force will be there. In air, less density, less number of particles, so less force. Absolutely, the net force acting on this one will be downward. Clear? Now you see this one. It is half is inside and it is half outside. This point is exactly on the surface. So this force maybe get cancelled. So again the same situation, the force will be in this direction, net force will be downward. And even if you consider here adhesive force, we know this adhesive force is less when compared to the cohesive force. Then automatically try to understand, throughout on all the surface, all the liquid particles will execute the downward pressure. Force is more, correct? So when force is more, all the liquid particles has a tendency to go inside. All the liquid particles has a tendency to go to inside only. But generally we are not seeing that one. We are not observing, right? When I am considering a glass of water, on the top layer, if I will see that layer, particles will not go inside. It will be stable only. It will be stable only. How it is possible? How it is possible? Try to understand. See, for example, here one string is there. One string. The rope is there. For example, rope is there. So here one person is holding this rope, and here another person is holding this rope. Right? Correct? I told strictly the rope should be straight. Rope should be straight. Now you tell me. I put one some mass. I added some mass here. When I added mass here, the shape becomes like this. Then I told, alright, you have to be. It should be stable. It should be in the horizontal. Then what they will do? They will pull. So from here he is pulling in this direction. From here he is pulling in this direction. So at this point it is in this direction. At this point it is in this direction. If this force is not there, just try to understand. It is a particle here, right? This one is a particle. On this particle, if this force is not in this direction or this force is not in this direction, the particle will go down. Particle will go down. In order to avoid that situation, the upper surface, the particles on the upper surface has act in such a way that it acts as a stretched membrane. That means it is 2D I'm showing here. So if I want to see if it is a 3D, so if the point is this one, it is going down. The particle is going down. So the neighboring particles has to avoid that. So here some tension will be there, here some tension, here some tension, here some tension, here some tension, here some tension. It is like a stretched membrane. It is like a stretched membrane. This property is called surface tension. Due to surface tension, that's why it is named as surface tension. Tension on the surface of a liquid layer. Tension on the surface of a liquid layer. Due to the surface tension, the liquid surface acts as a stretched membrane. Clear? This phenomena is called surface tension. I hope you understood, right? Surface tension is due to intermolecular forces. Surface tension is due to intermolecular forces. So due to the surface tension, outer layer or the upper layer is acts as a stretched membrane. Right? Try to understand. Just I will give the notes, right? See here, definition of surface tension. Try to understand. Surface tension means the property of a liquid due to which its free surface tries to have minimum surface area and it behaves if it is under a tension like a stretched membrane is called surface tension. So here one word is here. It wants to be in minimum surface. Right? Why? Because just try to understand, when we pour one water droplet, the water droplet will not be like this. When I pour some water droplet, the water droplet will not be like this, right? How the water droplet? The water droplet will be like this. Why? Because it wants to occupy the minimum surface area. Here tension is there, here tension, here tension, here tension, and here tension. Due to the tension, it wants to be in minimum surface area. Clear? And he is saying that it is due to the intermolecular force among the liquid molecules. That's what we discussed actually. Clear? I hope you understood, right? Surface tension means it is only due to the intermolecular force of attraction. So when we discuss about the intermolecular force of attraction, two types of forces are there. One is cohesive force and second one is adhesive force. Cohesive force means the force between the two same type of molecules are called cohesive forces, and the force between two different type of molecules are called adhesive force. So in the liquid, the upper layer, if you observe, we already discussed, upper layer, if you see, the more cohesive force is there, so the net force acting will be downward. So net force acting will be downward means if you see the top layer, the particle has to go down. So particle is not going down. Why? Because from here, I am stretching. So the particle will be stable. Clear? That's why balloon is this one, right? When I blow the balloon will be this one. When I pinch, then it will tear like this. When I pinch, it will tear like this. Why? Because it acts as a stretched membrane. It acts as a stretched membrane. Why? Because at every point the force will be acting in this direction, outward. So when we put a small hole, then automatically it will go like this. Clear? So this is the first property, which is surface tension. And in the next classes, we will discuss about what will be the formula and how to do some numericals also. We will try to understand. Clear? I hope you understood today's topic, right? Thank you.